Hello and welcome. I'm Brian Mates. This video shows you how to interact with some great new weather visualizations. They're part of a companion lab manual for this great textbook, and it will be offered by the AMS Press in 2017. The electronic materials are free online as a wing of the MAPES IDV collection. You can find the catalog of that at this URL. Drill down into IDV bundles, classes and labs, LMT manual materials. LMT means Lachman, Mapes, and Tile, our crew of authors for this lab manual project. Let's browse the visualizations, organized by book chapter. The early chapters align with the Lachman book chapter numbers. Chapter 8 here is a case study of winter precipitation type near the 0-degree line, which I'll demonstrate later in this video. I've made a folder here called Contributed, where I hope we might crowdsource some cases for the West or for Asia or for Europe, since most of our exercises are for the Eastern U.S. Any of our bundles that have the suffix MERA 1979 to 2015 can be used to tap online archives of this great NASA reanalysis, often with satellite pictures from NOAA aggregations as well, and any that have the RT suffix tap real-time data streams for today's weather. With either one, you could relocate our same displays in space and time to your area of interest and save off a zipped-up case study as a reliable and long-lasting resource. If you want to share those, keep in touch, mapes@miami.edu. Notice that you can get a quick look image of each bundle here by clicking the thumbnail. Without the manual, these aren't quite self-explanatory, but meteorologists may recognize some of the stuff in the legend and get a sense of it. Let me walk you through a demo of the first and last ones in our set here. So once you've taken a few steps here to install the MAPES IDV collection on any network machines, Mac or PC or Linux, then anytime you launch the IDV, you'll see my favorites folder in your toolbar here in the IDV window. The folder contents will update to the latest material every time you relaunch the IDV, so watch for that contributed folder to appear. And if you find any bugs, we can fix them for everyone in the world, so please keep in touch again. To load a bundle, you just select it in the folder tree, like this, and IDV will now go fetch the zip file from my server, unzip it into a temporary directory that gets cleaned out all the time, and create a bunch of displays for you. This one is a lesson on the jet stream, which is depicted as a green sausage here where the wind speed exceeds 40 meters per second. The display is 3D, so we can rotate the view over from the west, and cross-sections here would illustrate how the jet stream is related to gradients of temperature or to the slopes of the contours of potential temperature theta, obeying what is called the thermal wind relationship. So that's a nice classroom demonstration there. Let me show you our last and biggest bundle here from Chapter 8. You see the file size here is 175 megabytes, so I've preloaded it for this video. You can always check your computer's memory under a hidden thing here in the corner, and it's a good idea to close other big computer processes so that the IDV behaves smoothly and quickly for you. This is a high-resolution model simulation of a winter precipitation event from 2003. Colors here show surface precipitation as a sort of pseudo-radar data simulated by the model. And the white line is the 0-degree, the freezing line at the surface. So who's getting rain and who's getting snow from this storm? Well, the model's rainwater field here, you can see, doesn't cover all the radar. But the snow water field in blue does, and in fact, if you rotate over to the east view here, you can see that the snow extends down to the surface north of that 0-degree line. So if you look high enough in the atmosphere, it's all snow, but how it reaches the ground matters a lot to people. Does it melt to rain, and then does the rain refreeze, making dangerous frozen rain? So if we turn on a cross-section here and get these isosurfaces out of the way, you can see that sub-freezing air temperatures are undercutting the rain, and this could lead to freezing rain in this event. Now, that undercutting of or overhang, if you like, of the 0-degree isosurface is actually caused by the precipitation itself, the melting and evaporation. So it's a fascinating challenge to model and predict that accurately and make that forecast. So we hope you'll enjoy these resources and that meteorology teachers might find the LMT Lab Manual useful enough to want to support it. So keep in touch, and thanks for your interest. Bye for now.